Okay. Today we continue our discussion on boundary layer. So we are going to answer question number 4. So as shown in your screen, question number 4, the laminar boundary layer velocity profile is given by F eta equal to 2 eta minus 2 eta cube plus eta by the power of 4. So this symbol, you can call this symbol as eta. Okay, sometimes in a boundary layer, they will give you velocity distribution in terms of eta. So I hope, please do not surprise, because eta is actually the simplified version of normal velocity distribution. So previously, in a velocity distribution, we write as in term as u over u. So if you look back into our first tutorial, so I give you one of the velocity profile as 2y over delta minus u y over delta cube plus y over delta by the power of 4. So, but some researcher, they don't want to use the term y over delta, because y over delta will make our differential work, our integral works a little bit difficult. So what they do is they replace the terms y over delta with eta. So as stated here. So, and then if you change the y over delta into eta, means you need to change the terms of u over u here. So when you use eta, you must make these two assumptions. One is f eta is equal to u over u, and the other one is eta is equal to y over delta. So I hope if you have question, whether it is written in u over u or y over delta, or any question that showing your velocity distribution using eta, so I hope you could answer it. Okay, so in this example, we give you velocity profile by using eta here. So it can be written as 2 eta minus 2 eta cube plus eta by the power of 4. So please remember, the assumption that we need to use is f eta, mean function of eta. So you could read this as function of eta. So function of eta is u over u, and eta is actually represent y over delta. So the same question, so we need to express what is the delta star over delta and theta over delta. So what we need to do is, first, previously, we know that the equation for delta star is given like this. So integral 0 to delta 1 minus u over u dy. But if your velocity profile now means at this stage, at this condition, it doesn't have any terms in dy, in y or in delta. So means that we cannot use this equation, because this equation, it has u over u. But if your velocity profile doesn't have u over u, means we need to use another equation. So what we need to do is we need to transform this equation, mean this delta star equation that has dy u over u dy, into equation that have eta. So the answer is like this. Okay, so I will explain you the transformation between the equation here into the equation here. So first, okay, we assume that eta is equal to y over delta. So, and then if we do the differential, So we could say that d eta is now equal to dy over delta. So, and then we could change it into dy is equal delta d eta. So in this stage, okay, please make sure that you write d eta is equal to dy over delta, because delta here is actually a fixed amount. So mean we do not have a d delta. Okay, so we have d eta dy, because we want to relate between eta and y. That is the reason. So I hope you could understand. Please remember that we make differentiate d eta dy. So, and then we rearrange the terms. So we have dy equal delta d eta. So I think you already know why we need to do this, because we want to replace the term of dy here with the new terms here. Okay, so that what we do, we replace u over u here with f eta, function of eta, and then we replace dy here with delta d eta. So you could see that the value of delta d eta we could get from this transformation. So, and then if you see the integral here, you will find that the limit is from 0 to delta. However, our integral is by d eta. So means we also need to change the limit here. So how to change the limit here? It's easy. You could refer to this. You could refer to this term. So for example, if y equal to 0, so you substitute 0 here, you will find that the eta is equal to 0. So, and then if y is equal to delta, means that you substitute here with delta, and then you could say that eta is now equal to 1. So then we could make conclusion, equation for delta star, if you want to use u over u dy, you should use this equation. But if you want to use eta, okay, your delta star now will become like this. So integral 0 to 1, 1 minus f eta delta d eta. Okay, please make sure that you use the correct equation. So, and then this is for your notes. So for displacement thickness, this is the equation. So delta star over delta, integral 0 to 1, 1 minus f eta d eta. And the equation for momentum thickness will become theta over delta is equal integration of 0 to 1 f eta in bracket minus 1 minus f eta d eta. So I hope you could derive your own equation if you forgot about this equation. So the way that you could use is please refer to this step. Okay, so let's say we have a velocity profile of this one, okay, by the power of 4. So this is the equation for delta star. So what you need to do is we substitute the value of f eta here into this equation. So now we have this one, and I think it's look simple. You could do the integration straight away. So for example, from here, you could have integration of this one, and then we substitute the limit from 0 to 1, and finally you will get delta star over delta is equal 3 over 10. So, and then I hope you could do the same things. So I leave it simple as this one, because I hope you could do your tutorial at home after this. So this is the equation for delta, for theta over delta. And then what we need to do is we substitute the value of f eta here. Okay, so this is the value of eta, of f eta. So you substitute all of these function into this one. So what you need to do is you need to expand the term. So means you need to multiply f eta with 1, and at the same time you need to multiply f eta with another f eta here. So mean first you need to expand your terms, and then you do the integral. You substitute the limit from 0 to 1, and finally you could get 37 over 315. So the same answer will come out. You will get the same answer whether you do by using the eta or by using the u over u method. So it's okay. Both will give you same answer.